Here's an alternate version of it. So I wrote a little program as the function, and it takes in arguments x and z. And so for premise 1, it's if x, then z. So if x is true, then it will come in here and evaluate this. And so if x, then z. So if it is the case when x that not z, then it will throw an error, and it'll say the case, and it'll show us what the case is. It'll say that that's false because z is false when x is true, and that violates premise 1. And we got premise 2. If z, then not x. So if z is true, then this will trigger. Then it'll go into here. And if it is the case that x is true when z is true, then it will throw an error because that violates premise 2. If z, then not x. And if neither of the premises are violated, then the case is valid, and it will tell us that. And so now down here, I have it pass in x is true and z is true into it, and it'll show us the error if there's an error, and then we've got x true, z false. Same situation, and then x false, z true, and x false, z false, and that's all of the things. So now we'll just run it. Oops. Actually, I have to run it. There we go. All right, so we've got an error. The case x is true and z is true is false because x is true when z is true. And then we've got another error. The case x true, z false is false because z is false when x is true. And then we have a valid case where x is false and z is true, and a valid case where x is false and z is false. So every case that is valid, x is false. And in fact, every case where x is false, both premises are true. So there's a computer program also performing the same logic and coming to the same conclusion.